Alright, well now we're going to look at even and odd functions. Even functions are symmetrical on the across the y-axis here. Notice you look at this, you see that there's symmetry. You can fold them over across the y-axis, and what changes between these? The x changes their sign. You notice right here we have 2, 8 and negative 2, 8. So your x's will always change signs in order for them to be even functions, and y is going to stay the same. So you notice our x changed and our y stayed the same. Now for odd functions, they're able to be rotated around the origin. Alright? And what stays the same here? Nothing stays the same. Both the x's and y's are going to change their signs. So if you got 3, 5 here, then on the other side of your graph, you're going to have negative 3, negative 5. So both your x's and your y's will change signs. So describe the characteristics of an even function that you can see on the graph. Now we call f an even function if f of x equals f of negative x for all values in the domain. So x changes signs and y stays the same. Symmetry about the y-axis. So your x's are going to change signs, your y is going to remain the same. Now the same exact y, and your x is just going to change signs. Alright, in number 1, a point. Alright, so we're going to look at number 1. So let's see if number 1 right here. Number 1 is an even function, because if you look at these 2 points, we got 1, 2, and negative 1, 2. Notice our x values change their sign. And our y values stay. Alright. Number 2. Describe the characteristics of an odd function that you can see on a graph. F of x of an odd function is f of negative x is equal to negative f of x for all values in its domain. So what that tells us is that both x and y change signs, and they can be rotated around the origin. If you look right here, I can rotate this one right here around the origin. I'll get the same figure 180 degrees across from it. Alright. Is number 2 on the graph. 3, 3 is negative 3, 3 on the graph. Explain, yes, f of x is odd, and we'll look right here at number 2, and I chose 2, 3, or excuse me, 2, 2 and negative 2, 2. We could have chose 3, 3 and negative 3, 3, but notice both our x and y values both change signs. Alright, there, I got a 2, 2 and a negative 2, 2, so that makes that odd. I can also rotate this around the origin, and I'll get the exact same line. Alright. Number 3, describe the characteristics of an odd function that you can see. Oh, we already did that, excuse me. Alright, function 3 is an even function. Prove this type of function using the definition and by observing it on the graph. Alright, so graph number 3. Graph number 3 is an even function. So if you look right here, and we plot our points 1, 1 and negative 1, 1, it's symmetric over the y-axis right here. So if I fold it over, it'll be the same. And my x value changed its sign, and my y values stayed the same. Alright. Number 4, function 4 is an odd function. Prove this using definition by observing on the graph. Number 4, and I just put some points here. 1, 1, negative 1, 1. Both our x's and y's have changed. Alright, sign. And I may also rotate this around the origin, and it'll be the same exact function. Alright, That's x cubed. And also, notice the exponent here is an odd number, even number. Alright, notice my exponent here for this one, which was an odd function, is an odd number. Now f of 2 is different because it doesn't have any variables in it. And this may not always be the case, but this is just a quick way to kind of see it. Alright. Next. Describe function number 5. Alright, function number 5 is symmetrical over the y-axis. Alright. And I just showed a point. 2, 1, negative 2, 1. Notice the x values changed and the y value stayed the same. Also notice your exponent is even. Alright. Now the next one is neither. There's no symmetry here. I cannot rotate this graph about my origin and it become the same graph. Also, if I plot some points here, so if I plot 0.5 and 2, if I plot 0.5 and 2, that's not, I don't have any negative 0.5 and 2 here, and I don't have any negative 0.5 and negative 2. It's not going to cross, so it meets none of the criteria for even or odd. Alright. Suppose f is an odd function and the point negative 2, 8 is on the graph. Name one other point that must be on the graph. Well, we know if it's negative 2, 8, then we got to change both of our signs. So negative 2 will become a positive 2. Positive 8 will become a negative 8. So both of our signs have changed, therefore this is an odd function. Alright. So suppose f is an even function and the point 2, 7 on the graph. Name one other ordered pair. Well, negative 2, 7 would have to be another ordered pair here because if we look right here, our x value has changed. So it went from positive to negative. Our y value, it stays the same. X change. Alright. Well, that's pretty much even and odd.